All right, ladies and gentlemen, good morning, and for those that are watching this in the afternoon, good afternoon. All right, as you can tell, I am not here today, so we are still going to be expected to maintain our pacing. I wanted to make sure that we talked about a section of symmetry in the coordinate plane known as reflecting. Reflecting and distance are two very key components to not only the CFA that you'll be taking this week, but also for 10 ready testing at the end of the year. So it's imperative that we understand what reflection is and what distance between 2 points is as well. So as you can see, what's in front of the camera right now is a which is a lesson, but this lesson is not in your iReady books. You're going to have to use paper for this today. Um, the iReady book does not give us a proper lesson in terms of reflections and reflecting points and shapes and images. So I'm pulling a lesson out of not iReady, my bad, Eureka Math. And so we're going to be using the Eureka Math lesson to teach us about symmetry in a coordinate plane. So again, what we're going to be talking about is reflecting, okay? So when I want you to think about it like this, when you look in the mirror in the morning time, and that's when you're starting to put on your makeup or starting to fix your hair or brush your teeth, when you look in the mirror, okay, and you hold up your hand, you may be holding up your right hand, but what's happening is it's going to be your left hand in the image. It looks like the left hand is what's being held up. And that's what we're going to be looking at when we're talking about reflecting points. We're going to be talking about how they could look similar, but at the same time they're going to be different. There are very many aspects to reflecting points and shapes that are quite easy to get a grasp of, and there's others that seem to cause some difficulty. Okay? But I just want you to remember the idea of looking in a mirror and how a reflection in the mirror is not identical, okay, but it is similar. Okay, so that's what I want you to remember about this. We are talking about a point or a shape that is similar to the original, but not identical. All right, and there is going to be a breakdown, okay? But let's get started with what we're going to be working on, okay? Some of you, of course, I'm a little stuttering here today. I don't know what's going on. So my math lab classes, you already have Eureka math books. So if you have them, I opened up to lesson 16, S65 in that book, and you can follow along. You should already have completed this in Miss Hunt's classroom. So you do have that option to be able to follow along and make sure that maybe Miss Hunt and I are teaching the same kind of thing. If we're teaching it a little different, you're getting two perspectives here, okay? And that's always a good thing to have. So let's get started, okay? Lesson 16, Symmetry in the Coordinate Plane. All right, the opening exercise is to give an example of two opposite numbers and describe where the numbers lie on the number line. How are opposite numbers similar and how are they different? Okay, so here's the thing. I think about it like this. Okay, so we've already talked about opposite numbers, and we've talked about how opposite numbers are plotted on a number line. So if I sat there and said, you know what, I'm going to list the number -5, okay, and I want to know its opposite, all right, well, what I do is I go ahead and draw a number line, all right, pretty little number line. I got 0 in the middle, 1, 2, 3, 4, and 5. Here's a -5. And then I go 1, 2, 3, 4, 5, +5. All right, so in order for me to determine where a number is its opposite, what we do is we find out the distance the number is from 0. So here's 0 right here. So how many units does it take for me to go from 0 to a -5? Correct. It's 5 units. Okay? So the opposite of a -5 should be exactly 5 units from 0 going in the other direction. So 1, 2, 3, 4, 5 units. So I draw my line again, and sure enough, 5 units away is the number 5. So a -5 and 5 are the opposites. Okay? And we see this on the number line. Now, how are opposite numbers similar and how are they different? Well, similarities are actually quite easy to identify. Okay, similarity. All right, one, they have the same absolute value. Number two, what else can we sit there and think of? All right, you know that they have the same absolute value. I mean, technically they're the same number, just different values. But can we say they're the same number? I mean, technically, owing somebody $5 is not really the same as having $5. So why don't we just leave it at the fact that they have the same absolute value? Okay. You know what? I bet you somebody in there sat there and said they have the same distance. Now, I can tell you right now, there is a reason why I didn't list this first. And for those students who know, give yourself a round of applause right now, because the reason why I didn't list they have the same distance is because I already listed that in a way when I said they have the same absolute value. Because you remember, absolute value is a measure of distance. So when we say a -5 and 5 have the same absolute value, we are saying that they both have the same distance from 0. Okay? So that's the reason why I didn't really want to list distance, but I know some of y'all are probably thinking distance. All right? So differences. All right? One of the big ones. Okay? They have 2 different values. All right? Now, this is where we get to the fun stuff, okay? Now, there's also one other distance that we haven't really, one other difference that we haven't really talked about. And that's going to be the fact that, 2, they are on opposite sides of 0. Now, this is very important, especially when we're talking about reflections, okay? Because if you think of the 0 as the moment that we look into a mirror, all right? Here I am in the real world, and here I am in the reflection world. So in the real world, I'm a positive number. But in the reflection world, I'm a negative number. And this comes very, very important and very handy when it comes time for us to start looking at this reflection on a coordinate plane. Okay? So we're going to take this, and we're going to go ahead and push it a little further. So, example number 1. Extending opposite numbers to the coordinate plane. Excuse me. So locate and label your points on the coordinate plane to the right. For each given pair of points in the table below, record your observations and conjectures in the appropriate cell. Pay attention to the absolute values of the coordinates and where the points lie in reference to each axis. So, we're looking at basically a set of points here. So we're going to start off with the first, 3, 4, and a -3, 4. Now, obviously, 3, 4 is going to be in quadrant 1 because it's positive. Okay? So we go 1, 2, 3, 1, 2, 3, 4. Okay? So here's point 3, 4. Now I'm going to do a -3, 4. -1, -2, -3, 1, 2, 3, 4. Okay? So that's a -3, 4. All right, now we have our 2 points listed on the graph. So now it's time for us to identify some similarities. All right? First, all right, the similarities are both are 3 units from the y-axis. and 4 units above the x-axis. And I know what you're saying, Mr. Hale, how do you know this? Well, when I was plotting the points, I recognized that there was a pattern. All right? As I was plotting, I was still moving 1, 2, 3 units from the y-axis before I started going up. And then for the other point, I still counted 1, 2, 3 units from the y-axis before I counted up. So they both are the same distance from the y-axis. And they're both the same distance from the x-axis. And if you're never sure of it, just imagine drawing a little line that connects them. If they're on the same line, then they have the same distance from the x-axis. Okay? If the line is parallel to the x-axis, they're on the same line. Now, how are these coordinate points different? Well, it's easy. All right? One x value is positive, while the second is negative. Now, here's my question to you. Before we even jump into the next thing, before we continue moving on to the next point, I want you to start thinking about this now. All right? 3, 4 to negative 3, 4. These points are reflections of each other. So my question is, which axis are the points reflected across? And this is going to be for all 3 of these. And I'm going to come back to it and we're going to answer these questions. But as we are going through it now, I want you to start thinking about it. Which axis are these points reflected across? Okay? Are they reflected across the x-axis or are they reflected across the y-axis? I want you to start thinking about this now. So let's go ahead and continue. So we still have 3, 4, which we've already plotted here. But now the next point is 3, negative 4. Okay, so we're still moving a positive 3 on the x-axis. So 1, 2, 3. But this time we're going negative 4 units on the y-axis. So 1, 2, 3, 4. So what are some similarities here now? Okay, the person in the classroom, you are welcome to pause the video here real quick so they can start answering this question on their own. All right, hopefully we are coming back from a pause, so let's go ahead and answer this question. So some of the similarities, all right, they are both, so both have a positive 3 as an x value. All right, both 4 units from the x-axis. Now, what do we notice about some of the differences? Okay, so the y-coordinates, or the y-values, are known as opposites. All right? So if you're starting to notice now, there's a similarity between plotting 2 points that are reflections of each other. All right? One value will remain the same, while the other is going to be an opposite of itself. Now, that value is determined upon which axis is being reflected across. Okay? And I'm going to break it down for you here in just a second. But let's go ahead and take a look at the last one. All right? 3, 4 still, so we're still at 3, 4. Then we have a negative 3, negative 4. Oh, well, this is definitely new. So we go 1, 2, 3 on the x-axis, and then 1, 2, 3, 4 on the y-axis. So we're at a negative 3, negative 4. So now the question is, what are the similarities and what are the differences now? All right. Again, whoever is in my class today, please pause the video so my students can take the time to answer this question amongst themselves. All right, and we should be returning back from a nice little pause. So, some similarities of the coordinates. All right. Well, to make it easy, I mean, the only major similarities I can see is that both coordinates have the same absolute value. In other words, they are the same distance from 0 on both the x-axis and the y-axis. All right. Now, some of the differences here, same thing as before. All right, except now we're looking at both the x values and y values. All right, they're both opposites now. The x values and y values are opposites. Now, remember that question I asked you at the very beginning? Which axis are the points reflected across? So, if you've been thinking about it, point 34 and a negative 34 are reflected, okay, across the y-axis. All right? Points 34 and a 3 negative 4 are reflected across the x-axis. And then 3, 4, and a negative 3, negative 4 are reflected across both axes. All right. Now, I know that this is probably a little bit too much, so let me break this down in a little bit more of a layman terms, okay? So if you've been paying attention and you're looking at the notes, all right, look at the reflection for the y-axis, all right? Which values remain the same? They didn't change. Correct, the y values. So when we reflect across the y-axis, here's what you need to know. All right, 1, x values are opposites. 2, y values are identical. Okay? Now that's reflecting across the y-axis. What happens when we reflect across the x-axis? Okay, so that's what we're going to look at next. When we reflect across the x-axis. All right, so when we reflect across the x-axis, which we do here with 3, 4, and 3, negative 4, the values that remain the same happen to be the x values. The x values remained identical this time. So x values are identical, while the y values become opposites. Now, if both the x value and the y values are opposites, that means that those 2 points have been reflected across both axes. Okay? So that's going to be very important to remember. These are some of the most basic principles for reflecting points that you can get to. I know it seems like a lot right now, but I'm promising you, this is going to be okay. We're going to spend some time on this. We're going to hopefully get through what we need to get through this week, and we can continue moving on. But tomorrow we're going to be working on distance. I'll put in some reflective points for our bell work so I can make sure how many of y'all were actually paying attention in class today. All right, so be prepared for that. All right, let's go ahead and continue on, though. I want to make sure that we are all on the same page here. All right, so we're going to go ahead and continue past where we're at right now. If you need to continue taking notes, the person in my classroom is welcome to pause the video and let y'all finish taking notes, okay? I am perfectly all right with that. but I still got to continue because I want to go ahead and make sure that we got some things here. All right, so let's look at the next one. All right. So in this exercise here, in each column, write the coordinates of the points that are related to the given point by the criteria listed in the first column. All right. Point S, 5, 3, has been reflected over the X and Y axes for you as a guide, and its images are shown on the coordinate plane. Use the coordinate grid to help you locate each point and its corresponding coordinates. Okay, now, normally I would sit here and say, you know, I'm going to show you how to do all this, and we're going to work it all out together. But I gave you some very important information that can help you resolve this point. So what I want you to do is we're going to go ahead and pause the video here. I want you all to take about 7 minutes, give or take. Go ahead and work on this on your own and see whether or not you come up with the same answers that I do when we come back at the end of the 7 minutes, okay? So again, please, someone pause the video, and then we will come back after a short 7-minute break. All right, class, hopefully we're coming back from a small little break. So let's go ahead and get on to the next few things here. So as I was said, we were working on these 4 values, these 4 ordered pairs. And then we're being given information on the first column that tells us what happens to each of these points. Okay? So we got our first point, which is S53. All right? And it's saying the given point is reflected across the x-axis. Now, if it's reflected across the x-axis, remember what I told you, the x values remain identical. Okay? So if the x values remain identical, that means the first value for this is going to be 5. Okay? The second value, the y value, become opposites of each other. So the opposite of a positive 3 is going to be a negative 3. All right? And we continue on. Negative 2, 4. The x value remains the same. The y value turns opposite. So you should have gotten a negative 2, negative 4. For 3, negative 2, x value remains the same. Y value becomes positive. We should now have 3, 2. For the fourth point, the x value remains the same. The y value becomes opposite. The opposite of a negative 5 is a positive 5. So hopefully you got all of these correct across. If you didn't, remember what I'm saying. When you're reflected across the x-axis, the x values are the same, okay? And remember, ordered pairs are always written in x, y pairings. So that means the first value remains the same. It's the second value that changes. Now, if you change the first value, that's because you most likely mixed up the x, y order. Remember, x comes before y in the alphabet. So x is first listed in the ordered pair. All right? So let's take a look at the second restriction we've been given. The given point is now reflected across the y-axis. Now, remember what I told you about the y-axis. The x values become opposites. The y values are identical. Okay? So now we've got an x value that's opposite. So the opposite of a positive 5 is going to be a negative 5. The opposite, oh, wait a minute. There is no opposite of the y value. That remains the same. All right? The opposite of a negative 2 is going to be a positive 2. And the y value will remain the same at a positive 4. The opposite of a positive 3 is a negative 3. The identical y value is a negative 2. The opposite of a negative 1 will be a positive 1. The y value remains the same. It's a negative 5. Okay? So hopefully you got the first 8 correct. Now we get to have a little fun. Now we get to have a little fun. Alright, so the given point is now reflected first across the x-axis, then across the y-axis. So now we've been given 2 steps. Okay? The first thing that we had to do was reflect across the x-axis, which means we're just going to take the values that we were given and go ahead and write them from the first row. We're going to write them down here in the second row. So right now we're at 5, negative 3, negative 2, negative 4, 3, 2, and negative 1, 5. Now that is reflecting across the x-axis. Now I'm being reflected across the y-axis. And remember, the y-axis, The x values become opposites, the y values remain identical. So our answer is going to be a -5, -3. All right, now it's going to be 2, whoops, hold on. Yeah, 2, -4. All right, then it's going to be, let's see, what did I say? Oh, -3, 2. All right, and then it's going to be -1, -5. Interesting. Oops. Mr. Hale made a boo-boo. Mr. Hale made a boo-boo. He wasn't paying attention. This one should have been a +1, 5. My apologies. Okay? So if you look, all right, whenever you start off with, when you reflect across the x-axis and the y-axis, the values become opposites of each other. Both become opposites. All right? We have a -5, -3 now versus a 5, 3. Now we have a 2, -4 instead of a -2, 4. Now we have a -3, +2 instead of 3, -2. And now we have a 1, 5 instead of a -1, -5. So when you reflect across both axes, the values of the two numbers will become opposites of the original ordered pair. It doesn't matter which order you go in. And I'll show you that, because watch. Now the fourth column says the given point is reflected first across the y-axis. So now we're using all the y values that we originally had. -5, 3, 2, 4, -3, -2, and then 1, -5. That's reflecting across the y-axis. We've already done that, so all I had to do was take this row and copy it into this column. Now I'm being reflected across the x-axis, and in this situation, the x values are all identical, and the y values become opposites. So now we get a -5, -3. Now we get a 2, -4. Now we get a -3, +2. And now we get a Now we get a +1, -5. I'm sorry, my goodness gracious, what is going on with me tonight? All right, 1, +5, okay? So that becomes our value. All right, so -5, -3, 2, -4, -3, 2, 1, 5. And if you look, this column matches this column. Or sorry, this row matches this row. So it didn't matter whether or not we started with the x-axis or the y-axis first. The reflection is still going to be done the same way. We're still going to get the same result at the very end, and that's important to identify now. So you need to make sure you keep that little cheat sheet, okay? I'm going to make sure to put it up in the room too. I want to make sure we have that on the room, in the boardroom, all right, so you can see how reflections work. All right, so I think, let me take a look at the last two problems. I don't want to give you anything too much here. All right, so last two problems. All right, pretty easy in my opinion. Okay, given what we've talked about. So when the coordinates of 2 points are xy and a -xy, what line of symmetry do the points share? Okay, now I'm not sure how many of y'all remember lines of symmetry. Okay, but lines of symmetry is actually quite easy. So a line of symmetry is a line that is created that will allow a person or individual, okay, to fold something exactly perfectly over itself. Okay, so something like, do I have this? Okay, so I take this little piece of paper, okay, and if I wanted to, I take this diagonal line right here. All right, may not be perfect. I'm hoping it's going to be close to it, and you see it, okay. Now, if I'm able to fold, which I don't think I'm going to be able to fold this perfectly, and I'm going to be so disappointed in myself. All right, it's close, okay. All right, let's try it this way then. All right, so, all right, if I'm able to fold it right on that line, then I would get a line of symmetry, okay. It is a line which is perfectly right down the middle, which you can see my line is not, all right. A line that is perfectly down the middle of an object that allows for that object to be folded perfectly in half and on top, okay, you'd be able to see a perfectly folded piece of paper. That is what a line of symmetry is. Now, a coordinate plane has two lines of symmetry. Let's take a look at it. All right. A coordinate plane has two lines of symmetry. The x-axis is a perfect line of symmetry. Along with the x-axis, we have the y-axis. These two axes are perfect lines of symmetry. They divide the coordinate plane in half at any given point. Okay? So a reflection is reflected across a line of symmetry. All right? So let's take a look at something. So when the coordinates of 2 points are x, y, and a negative xy. So I want you to remember this, okay? Remember our coordinates. Or not coordinates, my bad. Our quadrants. When we have a positive, we're in quadrant 1. When we're in a negative positive, we're in quadrant 2. So what's the line of symmetry? Okay, what line would I have to fold across in order for a point to touch each other from quadrant 1 and quadrant 2? Okay, correct. It would be the y-axis. Okay, all right. And the reason why it's going to be the y-axis is because these quadrants are side by side to each other. All right. In order for them to be folded and touch each other exactly, they have to be folded over that vertical line. All right. The vertical line is going to be our line of symmetry. All right. Now let's take a look at number 2. XY again is quadrant 1. All right. X negative y. So we're still on a positive x value, but now we're going into a negative y value. That sounds like quadrant 4 to me. So what line of symmetry do the points share? Correct. It's going to be the x-axis this time. All right? And we know it's the x-axis because in order for a point in quadrant 1 and quadrant 4 to be able to sit on top of each other, we have to fold across the fold across the x-axis for us to have a perfect line of symmetry to exist. Okay? So remember, the axes are your line of symmetry. All right? They're going to be your friend in order to help you to sit there and navigate reflective points. Okay? All right, so that's the end of my lesson. We're going to sit there and talk more about this tomorrow. All right, we're going to discuss a few things. And when I say the end of my lesson, I mean the end of my Eureka math lesson. We are by far nowhere near being done just yet. So let's take a look at the last thing I want us to look at. Okay. Now, reflecting points is easy. All right. Reflecting points is always an easy thing to do because it's just one point. But what if we were going to reflect whole shapes? Okay. That's where things get a little interesting. So we have here Sophia. Now, this is in your books. I got page 132 in the iReady math book. I can't guarantee it's that same one for everybody. But again, this is page 132 in the books that I printed off. All right, lesson 14. It's talking about reflecting points. Okay? So somebody in class, please make sure that somebody else finds the page near you. Do not allow them to sit there with their books closed. All right? Again, it's lesson 14, reflecting points. It's on roughly page 132 because that's the page I got printed off in my paper here, okay? All right, so Sophia draws 3 triangles. What is the relationship between the coordinates of the vertices of triangle ABC and triangle DEF? What's the relationship between the coordinates of the vertices of triangle ABC and triangle GHI? So we got ABC here, and then we got DEF. And then we got triangle ABC and GHI. All right, now vertices. Okay, that is a new vocabulary word. But vertices, okay, they are the points at which 2 lines meet. In other words, the corners. In layman's terms, it's going to be the quarters. All right. So the vertices are where 2 lines meet to form a corner. Now, you've been given these 3. And what they're asking for is what's the relationship between them, okay? So if we look at the relationship between ABC and DEF, what can we say about these two triangles? Okay, now I'm hoping somebody in the class chat room said, Mr. Hale, these two triangles are reflections of each other. And if you did say reflections, good job, I'm proud of you. If you didn't, I hope you use some form of reflections, okay? Now the question is, though, is which axis? Let's go with which axis. Which axis is this triangle reflected across? All right, good. If you said the x-axis, that is great, okay? It's true. These 2 points are reflected across the x-axis, all right? Now, to make sure you understand that, I'm going to use one of my handy trusty little pens here. All right, look at point B here. All right, point B is exactly 1, 2, 3 units from the x-axis. Its reflection is not point D, it's point E. So point E is its reflection, okay? And that's reflection is at 1, 2, 3 units from the x-axis. Same thing for C here. C is 3 units from the x-axis. Its reflection is point B, and it is 3 units from the x-axis. All right? Now, point A happens to be 7 units from the x-axis, and its reflection happens to be 7 units from the x-axis as well, also known as point D. All right? So your reflections, when you are reflecting your points, they're always going to be the same distance from the axis in which it's being reflected over. Okay? So remember that. All right? Each point will maintain the same distance. Okay? Each point maintains the same distance from the axis that it is reflected across. All right, so each point maintains the same distance from the axis that it is reflected across. That's important. Okay? So if you are able to identify that information, then it should be easy for you to be able to complete the rest of today's lesson. All right? You have a wonderful teacher in there that's going to help you out, help guide you through this process. If it's Miss Gardner, then I know she's going to sit there and help you guys out as needed. If it is somebody else, then I know they're going to do the same thing. I'm not worried about it, okay? Now, for those that are still in my class, because you should still have about 15 minutes left, okay? If you look on the next page, 133, okay, there are about, 1, 2, 3, 4, 5, 6, 7 problems. 7 problems. That is what I want you to work on in class today. That's what I want you to finish. All right, leave it in your books. You're going to show it to me tomorrow. All right, when it's completed and it is shown to me tomorrow, you will receive your grade. All right, so make sure you do not forget. Complete this before class tomorrow. All right, this is your assignment. All right, guys, I hope y'all have yourselves a wonderful day. I will see you tomorrow. For those that are wondering, my wife has a doctor's appointment today. That's the reason why I'm out. I'm going to be there with her. All right, so I will be back with you guys tomorrow morning, bright and early. All right, y'all. Love y'all bunches. Y'all have yourselves a wonderful day, and I'll see you tomorrow. All right, bye.